Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can an investigative agency assign 7 cases to 5 agents in a one-to-one assignment? We are asked here about the total number of ways. Hence, let's look if we could use permutation here. Permutation can be used with the following conditions. Number 1, there should be no repetition. Looking into that, if a case is assigned to one agent, then definitely it can no longer be assigned to another agent because it's strictly one-to-one assignment here. This automatically means that there are no repetition of cases to agents. The second one is whether the assignments of our case to our agents when rearranged will be counted differently. That's for permutation. Permutation allows us to count additional ways if we are going to interchange arrangements. And of course, it's very obvious. Say for example, case number 1 is assigned to agent number 1 until case number 5 is assigned to agent number 5. If we are going to rearrange that, say, give case number 1 to agent number 5 and case number 5 to agent number 1, that's another way of an assignment. So with those two in mind, permutation is now possible to be used here. The formula for permutation is in this manner: NP R, telling us the possible number of n and the number of objects taken at a time. So we have here 7 cases. The number of agents is not part here, but it tells us the number of cases that will be taken at a time because it would be one-to-one assignment. Therefore, each agent will be given 1. So 5 agents, total of 5 cases at a time. So we simply plug this one on our formula here, which is n factorial over our n minus r factorial. By the way, if you're using a calculator there, you can all automatically plug in these two values here. You can type this in your calculator, 7p and r, which is in this case 5. You will automatically get the result. But if we are talking about showing a solution, so we're going to do it like this. Our n is 7. So you have 7 factorial over, you will have here 7 minus 5 factorial. Okay, take note that n factorial, or in this case 7 factorial, in general, again, that's n factorial, is the condensed way of writing products of integers 1 until n. Or in reverse order, we have n times the number before it, because if n is 7, the number before it is 6, that's 7 minus 1, 6, times the number before it, so you have n minus 2, until you reach a product with 1. So that would mean for our 7 factorial, our numerator here, that's 7 times 6 times 5 times 4 times 3 times 2 times 1, or let's just simply end here. Of course, I could write 2 factorial as 2 times 1, but since our denominator is already 2 factorial, that 7 minus 5 is 2 factorial. Of course, I could also break this to 2 times 1, and you have your 2 times 1 in your numerator. You can still cancel them, but just by writing this, aside from I don't have much space, this automatically means that my denominator is just 1, and proceed with the product of our numerator. That's 7 times 6 times 5 times 4 times 3, which gives us a result of 2,520 ways. So for our investigative agency to assign 7 cases to their 5 agents in a one-to-one assignment, there are actually more than 2,000 ways to do that. This is the result for this item, to which we already satisfied the conditions for permutation, because again, permutation allows us to count the number of arrangements that can be done even on the same number of assignments with same agents. In this case, if the assignments will be interchanged, then they are counted differently. So we have this answer for this situation. And that's counted in. Talking about getting the luck of the draw. For all in, subscribe now.